first of all,
Does this have G codes with it?
yep, we're going to post it out in just a minute.
Okay. I was just wondering.
So Rhino.
I was wondering if it was just a picture or if it had all the G codes and everything else with it.
Oh yeah, I'm going to show you. Yeah, I'm going to show you the programs that came with it. Okay.
Okay.
So RhinoCam is a completely integrated plugin with Rhino. So anything that you can open or load or model inside of Rhino, you can program toolpaths with RhinoCam. So let me go ahead and I'm going to load RhinoCam mill.
Okay, I see that.
So what we have over here on the left is the milling browser for RhinoCam. Okay. Now, the program the file that you sent had some programs already machined in it, okay? And I'm going to show you how to do those inside of RhinoCam, okay? So I'm going to leave these programs in here, but I'm going to show you how to go ahead and do them inside of RhinoCam, okay?
Okie doke.
And everything that I'm going to show you, you can do in the standard configuration of RhinoCam, okay? So let's go ahead and I'll just go through the basic workflow of how you set up and program any part inside of Rhino, okay?
Okay.
So basically all your commands that you need to program are right here in this browser on the left, okay?
Okay.
Now, you obviously got to have your model in Rhino, or you can just have 2D.
You broke up. Sorry, you just broke up there for a minute. I couldn't understand what you said.
Okay. Obviously, you got to have something to machine inside of Rhino, so you got to have your 3D part or 2D curves or whatever it is you're going to machine inside of Rhino. So what you do, it's got a program tab and a simulate tab. So from the program tab, you just work your way from left to right to set up your part and do your programming. Now, this part that you sent already had some tools defined down here. It's got a 3/8 inch flat mill and a 3/8 inch ball mill, and I'll show you how those are defined also.
Okay.
So basically, you just start from left to right. We'll start with the machine, and you can define it as 3, 4, or 5 axis. In standard configuration, you're going to be running in 3 axis all the time. So that's the default configuration for standard RhinoCam standard.
But there is some 3D in this, isn't there?
Yes, this is all 3D. I meant 3 axis, meaning 3 axis machining.
Okay, but I mean it all. I know when I watched the machining that they had to do some stuff that was 3D, which was third dimension because they had to taper things and things like that.
I'm going to show you that. So we got the machine defined. Let's define the post, and by default, their file was set to Laguna HHC, and we got over 300 different other posts here. So we'll leave that set to Laguna. And for the stock, what they had in this part is they had their bounding box for the stock already modeled. Okay, so you see that?
You broke up again there.
Okay, in this part that Laguna sent you, they already had the stock blank modeled already. Okay.
Right.
So we're going to go ahead and create the stock based on that blank. So we're going to go ahead and define the stock, and we're going to just copy the bounding box of the stock that's already modeled on the screen. Pick OK.
But if I had another piece, a different kind of of a different wood,
yeah, you can.
I would have to
set
this up.
Yeah, you can set whatever
because I already
you want.
Yeah, I have, because I already have 5 or 6 of these blocks made up in different types of wood to cut this guitar.
Okay.
And so I would have to change these parameters right here.
Well, if the stock are different, if it's different length and width and heights, then you can change those here.
In the dimensions.
Yeah.
Where it says length, width, and height.
Length, width, and height.
Okay.
You can change.
The only thing the only difference would be the length and the width. The height, so they're all the same. They're all the same thickness material that they
Okay.
made
Do you
up.
want to use a different length and width now to show you how to do it?
No, that's fine.
Okay. So we'll go ahead and use the length and width that they have already modeled. Once you define the stock, you don't need this block in Rhino displayed anymore. So we're going to turn that off. So we got the stock already defined. Okay.
Okay.
So now what we're going to do is we're going to go ahead and by default,
What did you press? What did you press to take off the stock then? I missed that part.
it's a toggle right here.
Where?
Down at the bottom here. See these toggles here?
Yes.
So the one on the left is for stock visibility.
Okay, so you took that off?
Yeah.
Okay, there it goes. Okay.
Okay.
I see it. Yes.
So we've got the stock defined. Now let's go ahead and make sure it's aligned properly. Now it's the same width as the part, so you know it's already aligned in the Z direction. But this is a good step to make sure you do this regardless of your stock dimension. So we're going to align the stock, and we're machining the top, so we're going to make sure it's flush with the bottom. So we're going to go, it's flush with the bottom in the Z, and we're going to center it in the X and Y. Okay, so that just guarantees that your stock is at the bottom of your part, okay, and it's centered in the X and the Y, okay?
How did you center it in the X and Y though?
Using the alignment here. We aligned it to the bottom in the Z axis and in the center in the X and Y.
Yeah, I don't understand how you aligned it.
Well, you use this align command dialog right here to align it.
And it aligns it automatic to
Yeah,
where you put the piece
does it
of stock
automatically
on the table?
Mm-hmm. Well, no, I'm talking about in the part file it's aligned. That's the way it's going to be when we program the toolpaths. When you put it on the machine, when you program, set this flush on your machine bed, you can zero out on one of these corners, and I'll show you how to do that in the program as well.
Oh, okay. I'm getting ahead then. Okay. I'm not sure what you would. I wasn't trying to screw you up. I was just wasn't following it.
No problem.
Exactly how you did that.
So
okay.
By default, there's a setup one already defined in your file when you open it, and it's aligned with your world origin inside of Rhino. Okay.
Okay.
So
yes.
the setup and the world origin in Rhino are in the same position when you start. Okay. And you can see that right here. I toggled it on and off. See that?
Yes.
Okay. So that's your machine coordinate system is currently aligned with your world coordinate system in Rhino, and you can turn the world one off too as well.
How do you know it's aligned then?
Well, it's in the same.
You hit that button.
Yeah, it's in the same position here. So by default, they're aligned when you open up a part. So what we're going to do is we're going to create a work zero up on one of these corners. So we're going to go ahead and create a work zero, and we're going to set it to the top stock box. And let's say you want to zero out on one of these other corners, say. Okay. You can generate a work zero. So now your work zero moved from here up to here. So now when you put the stock on, go ahead.
Where did you zero from? I wasn't following the arrow.
Okay, from the work zero button right here.
Okay, I see it. Yes, now I see it.
Okay. So now we have a work zero right there up here on the corner of the stock.
Right.
Okay.
Okay.
So now let's go ahead and we can set our material, and by default it's set to wood, and you can change this. There's only one wood, so currently you just leave it set to wood. Obviously you're machining this out of wood, I assume.
Yes.
Okay.
All different kinds.
Okay. So now we have this set up, we can start doing our toolpaths. So the first toolpath that they did was a pocketing in this inner area, and I'll show you how to go ahead and do that. So we'll go ahead and do 2 axis, and we'll select pocketing. Now you'll notice that this pocket is in different depths. You have one depth here, and you have another depth here. Okay?
Right.
So what we're going to use to machine the first pocket is we're going to select our curves to machine with, and you'll see that they have a curve already created for the boundary of this pocket.
Correct.
So we're going to use that. And for a tool, they have two tools already in here. Let's go ahead and show you how to create one. You just pick this Create Edit Tool button here, and you can define a different tool if you want to. Currently, they have a flat mill, a 3/8" flat mill, and a 3/8" ball mill. So we'll go ahead and use the flat mill.
Right.
Okay.
Okay.
And for the feeds and speeds, you can set these, you can assign these from the tool, or you can load them from a file. From the file just means it's a built-in calculator. Like if you wanted to change your tool material, it would change your spindle speed and your suggested cut feed rate and things of that nature. So you can change those here if you want. Okay.
Okay. But this is, most of this is already set, already into the program as far
Yes.
as the G codes and everything else already?
Well, no, there's default settings set in the program when you create a tool, okay? But you can override those, and you can change your feeds and your speeds, and you can change all the variables. But there's defaults already set for you when you create a new operation.
Okay, good. That's what I want to know, because I was, being the first time, I wouldn't know what speeds or anything like that is until I,
That's why
did
there's a built-in calculator that you can use based on the different materials and different materials for the tool, and it'll recommend a surface speed and a cut feed rate. It'll recommend values for you, but you can always override those and change them if you want.
Right. That's what I just wanted to make sure I could override it and change it if I wanted to, if it need be.
Everything that you need to do for any tool, any specific toolpath will be located in this dialog right here. So you got all these different tabs, and we're working in each one of these tabs. So we did our control geometry, we selected our tool, we defined our feeds and speeds based on what was defined in the tool, and we're going to go to the clearance plane. So this is your plane that the tool retracts to when it changes directions. And you can set that to an automatic distance. In other words, the program will determine a safe clearance, or you can tell it a specific distance above the part, and you'll see that the plane moves on the screen as you change it. So we'll just leave that set to auto. Go ahead.
Now the first tool that you're using basically is a flat one.
Yep.
So that will be basically removing most of the heavy stock to begin with, right? It's like a first cut to rough it out, kind of.
You can do it. You can use the pocketing as both a roughing and a finishing at the same time. So I'll show you that as well. So we'll leave the clearance plane set to automatic, and for the cut parameters, the stock, what you can do, the stock is measured in the X and the Y on the side walls, okay? So you can leave stock on the wall and then come in with a cleanup pass, say with a profiling operation. But for this demonstration, we're going to go, we won't have time to machine the whole guitar, so I'm going to go through and use some quicker parameters here. So we're going to leave the stock set to 0, so we're going to machine it right to the size of the pocket. You got all these different cut patterns you can use for pocketing, from offset, and the dialog shows you what they look like. And we even got a high-speed pocketing toolpath. And then also you can set your step over. Let's say 40% of the tool. So this is the XY step over. And
which means what? What does the step over mean?
Right here, if you look at this picture right here, the step over distance, that's the distance between the paths inside of the pocket. Okay.
Okay. So they would probably basically overlap, right?
Well, they would be offset. I have it set to offset, and the pattern will offset from the outer perimeter. I'll show you what it looks like in just a second. So we'll go ahead and do a cleanup pass. That means it'll clean up the perimeter at each level. And for our cut levels, for the initial pocket, we're going to cut down to this first level. So where is your location of your geometry? So your geometry is at the top of your cut. That's what you selected. So we're going to leave it at top. And for the total cut depth, you don't need to know your depths. You can measure them directly from the model. which is going to use the pick button, we're going to say, well, I want to cut, let's set my picks to endpoint. So I want to cut, say, from here to here. So it tells me that's 3/4 of an inch.
Right.
Okay.
Okay.
And then you can divide that up into how many passes, how many Z levels you want. So the rough depth per cut, let's say it at 1/4 inch. So it's going to make 3 levels. Okay.
Right. Okay.
Excuse me. Let me change that to 7.5. I meant put 1/4 inch down here. So the rough depth per cut would be 1/4 inch.
Okay.
Now, if you wanted to do a finishing pass at the very bottom, you can divide this up into rough depth and a finish depth also. We're going to leave it set to a rough depth. So there'll be 3 passes at 1/4 inch.
Okay.
So for the entry and exit, you have these different options for your engage motion. You can do a path entry, or you can do a linear entry or a helical entry. And then your retract motion, you can do a radial retract or a linear retract for pocketing. And you can apply those cut levels at each cut, apply those entry and exit motions at each cut level if you wish. So let's go ahead and generate this and I'll show you what it looks like. So what you see here is you've got an offset cut pattern based on, let's go to the top view and I'll show you that. So you got an offset cut pattern based on the shape of your geometry that you selected. So this is your offset distance here, okay? And then each Z level is your depth. So you can look at it each level too. So it's got 3 levels at 1/4 inch apiece. See that?
No, I don't.
You see the different levels here on the screen that are displayed when I select this?
Yeah, I kind of see them, but I don't see. I mean, I see the lines going up and down, but I don't see it like on the walls where it shows you how deep you're going.
Well, in 2 axis, so it only cuts in Z depths. It's cutting right up to the sidewall, okay? And this is the path at each Z depth, okay? We'll simulate it here, and I'll show you what I'm talking about. So there's your pocketing. Let's go ahead and run a simulation, and I'll show you what this looks like. So we'll go over to the Simulate tab, and we'll go ahead and select the operation, and then we'll pick Play. Let's slow it down a little bit.
What are the different colors for that are on the lines?
Okay, so the different colors is the different types of motions. The red are retract motions, okay? In the magenta is your engage motion. If I had a helical engagement where it started at, okay? And then the light blue are linear cuts and the dark blue are arc cuts, like radial cuts, okay? So let's go ahead and turn the toolpath off and we'll simulate that again a little bit slower.
So the red that's higher is just that's the path of the router just above the above the work.
Right, above right at the clearance plane. So it's going to transfer at the clearance plane over to these different areas to start cutting the pocket.
Okay.
Okay. So there's our pocketing for one level. Let's go ahead and do the second one for this deeper level here. So we'll go ahead, and if you want to use the same cut pattern, the same parameters, you can just copy your pocketing operation and paste it and create another copy of it. So we're going to open up the copy that we made. We're going to change our control geometry. We'll remove all that. And let's say that we want to use the bottom of this pocket to control our second pocket, which is the deeper end. Okay? So there's our...
Each different commands for, or a list of different commands for each different thing that you're going to be doing, like this level, the level you already did at 3/4, right. That's one
right.
Step.
In 2.5 axis machining, you're fixed at a certain level for each operation. Okay, so we did our first pocketing at one level, and then we're going to do the second pocket at the deeper level.
What about this other circle that's behind here, at that Yeah, that one.
That's a separate
It
operation.
didn't cut that one?
I'll show you that one too. In a
That's a separate operation,
yeah.
okay?
Mm-hmm.
Okay.
Now, if it was the same depth as this pocket, we could make it the same operation.
That's what I was thinking. I was thinking if it was going to do the 3/4, it would do everything
Okay.
on
Let's
the
see
whole
what.
car at once. No,
Let's look at see
that's
that.
not how it's set up.
Yep, it looks like it's the same depth. So we can go ahead and add it to this operation. So what we can do is we'll just add another flat area. Okay. So we're going to cut both of those at the same time. Now in the program, in the file that they sent you, it was in separate operations, but as long as it's at the same depth, you can do it in the same operation. Okay. So for our tool, we'll use the same tool, same feeds and speeds. And for the clearance plane will be the same. Everything else is the same. But for our depths, now one thing the reason that they didn't have this included in it is because this pocket here only starts at this Z level and goes down because this top part's already cut out. That's why they had it in a separate operation. You follow me?
But it's going to be cut in 2 separate levels, is it?
Well, this one, let me go ahead and finish it, and then I'll show you. Let me get rid of this one, and I'm going to show you. Let's remove that one. Okay. So let me go ahead and define the cut level. Since the top of this pocket's already cut, we're going to start our cut. We're going to say the location of cut geometry is at the bottom because that's where our geometry is that we selected. Okay. And then the depth of our cut is going to be from here now down to here. That's another 0.75. Okay. And we're going to do it at the same cut level. So let's generate. You'll see now that it just cut that bottom area. You see, because this top part was already cut. Now we're just doing the bottom area. Now let's simulate that. Slow that down a little bit. Okay? So now it's at a different depth. Now, that's why I divided it into two. That's why they had it in 2 operations, because this one has a different depth area. The top started here and the bottom was here. The bottoms were the same, but the tops are different. Okay? So let's go ahead and we can just copy this and do another one for our other pocketing. And we'll remove that and we'll select this flat area. And we'll just change our cut levels. Let's change do a near pick from here to here. So that's 1.5. Let's go ahead and generate.
It's the same depth.
Yeah, but it starts at the very top. This one only started at here, at this level here. You follow me? Now we could have, since you got 3 pockets here. You got this pocket here, which only goes down to this level here. Okay?
Right.
It starts here and goes down to there. This pocket starts here and goes to the deeper level.
Right.
And this one starts at the very top and goes all the way down to the bottom.
In one shot?
In one shot.
Oh, okay.
Okay? So
yes,
the way this is the operation that they had in there already. So we'll just ignore that. So we programmed those 3.
But it's going to, but this next pocket's going to be in different. It's going to be in different intervals. Again, 1/4 inch or something like that.
Which pocket? Where?
Time. The one that you're going to this last one, the oval.
Yeah, it's I copied it from this other operation, so by default it was set to 1/4 inch, and you can change that if you want.
Okay.
Okay, so all of the parameters for this pocket are the same as the ones for this pocket over here. So I just copied it, but I just changed the geometry and the depths.
Okay.
Okay.
Yep.
So we got those pockets machined. Let's see what they got over here for these other pockets. These are the ones they programmed. So they got this other pocket over here. Let's go ahead and program that one.
I think this guitar is a different. It looks a little bit different than the one that he cut on the video. This looks like the one that I guess your guy's name is Bob, Router Bob. Is that his name? His nickname?
That, you're talking about the gentleman with the, I believe he's with um,
The Laguna.
Laguna, yeah.
Oh, that's right. I'm sorry. You're not Laguna.
Yeah,
I'm
we're not
sorry.
Laguna. We're
I'm
the
sorry.
CAMJam.
Yeah, there's two different cuttings of this thing, and the guy that cut it the first time was really good, and he showed me he showed in the video different depths and how he explained everything a lot more in detail
Mm-hmm.
than they did on the one for this one here.
Mm-hmm. And it could be
It's
that he was
basically about this. It's about the same guitar, but he went through a lot more detail of how to cut it.
Mm-hmm. Now you can, all of these operations right now are 2-axis, so the depths are going to be the same for each.
Right.
In other words, the Z level is the same for the entire operation. Let's go ahead and machine this outer pocket here, and I'll show you. Let's see what they did here.
That was the tricky part, that neck.
Mm-hmm. So what he did was he created a boundary, okay, that was right at the top. Now you can also use the bottom of the boundary too, and you can also use, if you wanted to extend out past it, you can use this geometry here. Let's go ahead and create one and create it all the way out there. So it makes a clean break off of that. So let's go ahead and do a 2-axis pocketing. For the area that we're going to cut, let's say we're going to cut this large area to get a nice clean cut off the end of this guitar neck. And for the tool, we'll use the 3/8" flat mill, same feeds and speeds, same clearance. For the cut parameters, if you want to, you can use a different cut pattern, like a high-speed cut pattern. I'll show you what that looks like. Let's set the offset, change the offset to say 25%. I'm sure what it was. Let's say 30%. Show you something different. And for the cut levels, now where is your geometry at? It's at the bottom of the cut. And how deep do you want to cut? We want to go from here down to here. So that's 625. And you can have that divided up, say, in 0.2 levels or whatever, however level, how many levels you want to have. Let's say 125. Oh, sorry.
I thought the rough depth would be like at 7.5 instead of 6.2, because it said the total depth was 1.5.
Well, the total depth of you're talking about this pocket over here was 1.5. This is a different depth.
No, I thought it was the neck. The neck when you just brought it up before. That's where I'm getting confused too. Is in the programs now, do they have a difference between having it set in millimeters and rather than in inches for the Americans, or wood? Because millimeters is mostly for guys that are cutting metricans and stuff like that are cutting metal.
Yeah, you can do it in both. RhinoCam supports both inches and metric, and you set that in Rhino. Currently, it's set to inches.
Is it better to? I mean, I don't know which one's going to have more. If you get more info,
it doesn't matter. It doesn't matter. I mean, as long as your machine's set to metric or inches, if it's the same part, it doesn't really matter which units you use. You're going to get.
But it converts. But then the software converts it from millimeters, if you get it in millimeters, to inches?
Well, if you need to program it in the units that the part is in. This part is in inches. It's drawn in inches. Okay?
It is.
Yeah, so you can see it right here on the bottom of the screen. See where it says inches? At the bottom.
No, where is it? Where are you showing me?
I just right-clicked on inches down here, and it shows you the model units are set to inches.
Oh, it is. Okay.
Okay.
Then why is everything coming? We talking millimeters then?
No. Where did you see millimeters?
Well, when you're talking 6.6 or 0.26 is millimeters. That's not.
No, 0.625 is 5/8 of an inch.
Right. So it would be 5/8 of an inch rather than 0.62.
Well, no, it's in decimals. That's all. In other words, if you wanted to type in 5/8, you can. For instance, you can just type in here instead of 625, you could just say 5/8. Okay.
Okay.
And it'll take that. It'll just convert it to
Right.
625 because that's the decimal equivalent.
Well, that's what I'm used to is fractions and stuff like that. But most of what I've been watching is, it's decimals and stuff like that. So it's, I've been getting used to converting it, but,
Well,
I'm
in the
wondering,
dialogues, you can in our dialogues, you can enter fractions and it'll convert it for you.
Okay.
Okay.
Good.
See, as you see there, I just typed in 5/8 and hit enter, and it. Well, sorry, I hit enter. I shouldn't hit enter. It actually generated the toolpath. So in the cut levels, if you put 5/8, okay, and then you select another field, it converts it for you to 625 because that's the decimal equivalent. Okay.
Okay.
So let's go ahead and the rest of these parameters will be the same. Let's go ahead and generate this, see what it looks like. Well, that is different. Hold on a second. I got me changing the parameters on me. So let's go back over to the control geometry tab. Let's remove that and we'll select this for our control geometry this time. Use the same tool. With the cut levels, it's at the bottom. And for the total cut depth, we're going to go from here to here. So that's 5/8 of an inch or 625 for your total depth. And with your rough depth, you can change that. Your rough depth per cut, you can change that. Let's say 1/8 of an inch levels. And let's go ahead and generate that.
So this is a flat cut, this neck.
Yep. Mm-hmm.
Because in the picture that, the one that he showed had a tapered neck on it. It went from 0
yeah, this one's flat.
Okay.
So let's go ahead and play that. Oh, sorry about that.
It just matters. Depends on which neck you're going to use, whichever neck you're going to put in there.
Mm-hmm. And let's go ahead and let's move this up. So actually, let's move it up to here. And let's regenerate that. And then we'll play it. Well, sorry about that. The reason you're not seeing the stock is it's got these other toolpaths in there that aren't generated. Let's stop that. And let's go ahead and generate all the way down. Okay. So now you can see it. We'll move that a little bit faster. So there's the pocket for the neck. For this guitar, it's just a flat pocket. Okay.
Right. Yeah, that's okay. That's no big deal.
So there we have our, let's see what other 2.5 operations they have in here. Okay. They do have a 3-axis roughing operation over here. So what we did so far was just 2-axis.
Right.
Let's go ahead and do some 3-axis machining. So what we're going to do is you want to hog out some of this material because you don't want to, cut it all in one depth, like a finishing operation.
Right.
So let's go ahead and show you how to do the horizontal roughing. Let's remove that. And for the geometry, we'll go ahead and select. I already have a whole region selected. This region that you see here is all of your tapered surfaces, all of your curved surfaces. So this is just the area where those curved surfaces are. So we're going to use that area for the roughing. And we'll use the flat mill for roughing. And for the cut parameters.
I thought they used the ball mill on that.
You can, if you want.
I thought that's what they used because it was so nice and round that it made that nice round curve that way.
Mm-hmm. We can use it for roughing.
Well, I don't know if they used it on the finishing then.
Well, the finishing you do want to have the ball mill, but for roughing you can use the flat end because we're going to leave some stock on the part.
Right.
Okay.
That I remember.
But typically you use the flat mill for roughing and the ball mill for finishing. But you can use the ball mill if you want. We'll go ahead and use the ball mill. So for the cut parameters, we'll go ahead and do an offset cut pattern, and we'll do an offset, say, of 40% of the tool diameter. And for the cut levels, You don't have to enter, you don't have to tell it how deep it goes, because in 3-axis, it's always going to go, the surfaces are always going to drive your tool path, okay? We're only selecting geometry to tell it not to go outside of this boundary or outside of this boundary, okay? So it's going to stay in this boundary, and it's going to cut right down to the surface, okay? Does that make sense?
Okay. Yes.
Okay, so let's go ahead and generate that, and I'll show you that. So there's our roughing, and it got a lot of material out over here and less material here because there's not a whole lot of material to get out there. Let's go ahead and simulate that.
Right.
Okay, let's move that up here under this one. Let's regenerate that real quick, and then we'll play.
The horizontal roughing now that's all, it's the circles all the way around.
Yep.
And the
that's in horizontal roughing, and you can look at this in levels. Let's go back over here. You can look at this in each level too.
Yeah, you just showed. I just saw that you had it before.
Mm-hmm. That's at each horizontal level. That's horizontal roughing.
Yeah, I see it. Yeah, I see it.
So
I remember them doing it in the video too.
That's your roughing operation. So let's go ahead and do a finishing operation on that. We'll go ahead and do a 3-axis parallel finishing, and we can use the same boundaries, and we're going to do, for the tool, we'll use the ball mill. The cut parameters, we're going to leave a stock of 0, so it's going to go right down to the surface, and it can you can tell it the angle of your cut, whether it's going to cut this way or that way. And parallel finishing, you're cutting in parallel planes. So I'll show you what that looks like in just a second. Let's do a nice, say, 15% step over. Let's generate this. I'll show you what it looks like.
He also before all this horizontal stuff was done, he cut it with the rough mill all over the shape of the guitar all the way down to the bottom, and then left tabs. So when he did the rollover or the curve,
you got a model. Curve, yeah, when
he had it better.
Yeah, it's still connected. On this particular part that that you sent me, it had no tabs on it. But you, in certain operations, like in 2.5-axis profiling, you can leave tabs automatically.
Right, but this wasn't cut. The shape wasn't cut before, right? We hadn't cut that yet.
No, we haven't cut anything. This is the first side of the part that we're cutting. So what we're doing now, let's go ahead and simulate that. So this is our finishing operation. And you can speed that up if you want. So there's our finishing operation for the radius area, the contoured areas. And you can adjust this step over to get a finer finish too. Now, this side is basically done. So what you would do then, you're looking at the standard configuration. So you got to cut this in 2 different files. For one side,
the shape of it hasn't been cut yet either.
No, you mean the contour outside?
Yeah, the outside.
That's on the second. That's on the second side.
Oh, I thought they cut it from both sides, basically.
Well, they might have in that demonstration. In the part that you sent me, they only had it cut from the one side. So in this side, let's turn off the toolpath. You'll see that's what it looks like on this side. Okay.
Right. That looks nice.
So everything that's cut out, and then what you can do there is you can select. Let's take this one and move it down. Let's move it down here. Get it out of the way. So now when you post this, you can just select this one setup, and it'll post all these operations in one setup, or you can select just a couple of operations, or you can just select one operation and post it out. So if you want to run this whole thing out, if your machine had an automatic tool changer, you can just post out the entire setup, and it'll change the tools automatically and run the entire part on this side. And let's go ahead and post this. And let's see. Make sure we're in the right place, and let's post that out. So here is your G code for the Laguna.